Hi guys, Steve from Crossbow College here. If you've seen my tutorial on mounting your scope and you've correctly mounted your scope but it's not hitting the target where you're putting the crosshairs at, it doesn't mean that you've done anything wrong. What it means is that the focal point for the crosshairs in your scope aren't aligned with your weapon's impact point. Since your shots are going to go where your weapon is pointing, you need to put your scope's crosshairs on where the shot is going to be at. This way, when you put your crosshairs on the target, the focal point of your shots will be impacting where your crosshairs are at. Now, you're trying to figure out how to aim better, and in desperation, you've removed the cap from one of the turrets, and you are faced with this cryptic message for directions. Why does it say 1/2 inch or 1/4 inch? What if it doesn't say MOA at all? Well, even if you don't see MOA anywhere, other than perhaps in the scope's instruction booklet, it is safe to assume that your scope is set up for MOA, since that is the industry standard. The MOA stands for minutes of angle. Minutes of angle are used to help us zero in our scope and to compensate for different distances and wind conditions. That is why this lesson is going to be on explaining minutes of angle and how they apply to our making more accurate shots. Let's begin by looking at the concept of minutes of angle in the broadest sense. This means we need to first explain the degrees of a circle. If we look at a circle as though it were a spoked bicycle wheel, our wheel would have a total of 360 spokes, each coming from the center and going in a straight line all the way out to the rim. The red line to the right represents approximately 1 degree of arc. If we take one of these degrees of arc and further divide it into 60 equal parts, we come up with minutes of angle, or MOA. Unlike degrees, which extend out in a complete circle, the minutes of angle are only small portions of a single degree of arc and do not extend out in a complete circle for each hour's worth of minutes. Now let's see how we can put this information to good use. If we are shooting at a target that is 100 yards away and our focal point is on the center of the bullseye, we are going to score a direct hit. However, if we fire a shot at our target and instead of firing straight, we are 1 MOA off to the right, we are going to be off from the bullseye's dead center. But we have a way of measuring how far off we are from center, and that is the key to correcting the aim of our scope. Fortunately, we have a little fact that is going to help us with correcting our aim. That fact is, at 100 yards, 1 minute of angle is equal to 1 inch. Knowing how wide the gap is for 1 MOA at 100 yards gives us the information we need to base all the rest of our calculations on. In this example, we can see that the line on the left is in the 0 degrees position, while the line on the right is veering away from our center line at an angle of 1 MOA. At 100 yards, the deviation from center is 1 inch. If we go out to 200 yards, our 1 MOA continues to get farther and farther away from the center line, so that at 200 yards, our 1 MOA is now doubled, or 2 inches away from the center line. If we go out to 300 yards, our 1 MOA has continued to increase its gap and is now a 3-inch gap. As we can see, the farther away we go following our 1 MOA path, the farther we become from being on our center line. However, since we are using crossbows, making shots at 100 yards or farther is going to be a rare circumstance. Certainly, you would never want to be trying to hunt at those distances with a crossbow. Therefore, we are going to concentrate on shots that are going to be more in our range, with the 20-yard shot being our closest distance and 100 yards our farthest. Now that we know what a minute of angle is, let's use that information to help us aim better. Let's begin with a few assumptions. First, you've already put your crosshairs on a bullseye at 100 yards. You've fired a test shot. You've gone up and looked, and you now know how far off you are from hitting the bullseye. We can now use MOA to improve our aim if we know 3 things. the distance to our target. Okay, we know that. It is 100 yards. How far off we are away from the center of the bullseye. Okay, we've already gone and looked to see how far off we are, so we know that part. What increments our scope uses for making adjustments. This is something we can easily find out by simply removing the adjustment caps and looking at the turret. It will tell you if it is a 1 MOA, 1/2 MOA, or 1/4 MOA. For our first example, we will keep it simple and assume that our scope is set to make adjustments in 1 MOA increments. This means that when we turn the turret in one direction or the other, it is going to make a click sound. Each time it clicks, we are moving its focal point by 1 MOA at 100 yards. Our goal is to adjust that focal point so that it puts our shot directly in the center of the bullseye when we put our crosshairs on the center of the bullseye and fire. As we saw in our earlier examples, the further away you get after 100 yards, making a single MOA adjustment can move your shot by several inches. However, as targets come within that 100-yard range, a single MOA creates much less of a deviation, or gap. For instance, if we come in to only 50 yards away, our MOA gap is cut in half. As you can see in the example, at 1 MOA, by the time the bolt is going past the 50-yard mark, it hasn't had enough space to deviate an entire inch yet. This means that at 50 yards, a single click of our 1 MOA scope is only going to move our shot over by 1/2 inch. If we are over an inch off of dead center at 50 yards, we're going to need 2 clicks at 1/2 inch each to move our focal point a single inch. If we come into 20 yards, the most common range for crossbows, then we now need to take our 100-yard distance and divide it by 20 so that we get the number 5. This tells us that at 20 yards, each MOA is only going to be 1/5 of an inch. At this close distance, we are going to need 5 clicks or 5 MOA to move our focal point a single inch. In case you hadn't noticed, the closer we get to our target, the more complicated the math becomes. However, there is a benefit in that using these calculations at closer distances allows us to be very precise with our shot placement. For those of you who like charts, here is one on this topic. You are welcome to pause, but I'm going to continue with the lesson. Now we are going to move on to a scope that uses a 1/2 MOA adjustment. Just like the name suggests, this scope allows us to adjust the focal point in smaller increments, which is going to give you twice the precision possibilities that a 1 MOA scope could do. At 100 yards, it will now take 2 clicks to move our focal point a single inch on target. At 50 yards, with a 1/2 inch gap at 1 MOA, a single click of our 1/2 MOA scope is going to be 1/4 inch, meaning that at 50 yards we will need 4 clicks to move our focal point 1 inch. Coming all the way into 20 yards, we divide 50 by 20 to get 0.4 or 1/5 inch. This means that each click at 20 yards is going to move our focal point by 1/5 of an inch. It will take 5 clicks to move our focal point 1 inch at a 20-yard distance. Here's another chart for you if you feel like pausing. Now we are going to move on to a scope with 1/4 MOA adjustments. This means that at 100 yards, each click is going to move our focal point by 1/4 inch. As you are beginning to see, scopes that have the MOA broken up into smaller increments allow us to more precisely place our shots, even at a distance of 100 yards. At only 50 yards away, it's going to take twice as many clicks to move our focal point by 1 inch. This means that each click is going to move our focal point by only 1/8 inch. Once we come in all the way into 20 yards, our click is only going to move our focal point by 1/20th of an inch. With it now taking as many as 20 clicks to move our focal point a single inch, we have the ability to put a bolt on target at 60 feet away with extreme precision. Here's another chart for your consideration. Now let's look at how we can use MOA to fine-tune our scopes. In our first example, our target is at 100 yards away and our shot was exactly 3 inches off to the right side. If we have a 1 MOA scope, the adjustment is easy. Turn the turret 3 clicks in the indicated direction for left adjustment. If we have a 1/2 MOA scope, the adjustment is again fairly easy since all we have to do is double our 1 MOA calculations and turn our turret 6 clicks in the indicated direction for left adjustment. If we have a 1/4 MOA scope, the adjustment is going to be 4 clicks times 3 inches or 12 clicks in the indicated direction for left adjustment. In our next example, still at 100 yards, our aim is off by 2 inches to the left. On our 1 MOA scope, the adjustment is easy. Just turn the turret 2 clicks in the rightward direction. On our 1/2 MOA scope, the adjustment is also fairly easy since once again all we have to do is double the numbers. Therefore, at 2 inches to the left, we will be turning our turret 4 clicks in the rightward direction. On our 1/4 MOA scope, the adjustment is going to be 4 clicks times 2 inches equals 8 clicks of the turret in the rightward direction. Up till now, we have been working with MOA on the horizontal axis, also known as windage because it was meant to compensate for crosswinds that might blow your shot off course. However, MOA also refers to the vertical axis, also known as elevation. Now we can not only adjust our focal point either left or right, we can also move our focal point up and down, allowing us to put our focal point exactly where we want it. This is why your scope has 2 turrets for adjustment, an elevation turret on top for adjusting the up and down aim, and a windage turret on the side for adjusting the side-to-side aim. Let's take a look at an example of how we use the vertical axis or elevation to make adjustments to our focal point. Just like in our horizontal adjustments, we need to know the distance and how far off we are from dead center. In this example, we are impacting the target centered but 2 inches too low. On our 1 MOA scope, the adjustment is easy. Turn the elevation turret 2 clicks in the up direction. On our 1/2 MOA scope, the adjustment is also fairly easy since once again all we need to do is double the numbers. Therefore, at 2 inches too low, we will be turning our elevation turret 4 clicks in the up direction. On our 1/4 MOA scope, the adjustment is going to be 4 clicks times 2 inches equals 8 clicks of the elevation turret in the up direction. Now let's put this knowledge to the test. In this example, our group of 3 test shots are impacting consistently low and to the left, even though our crosshairs show it should be hitting the bullseye each time. First, we will adjust for the elevation. We move our focal point up about 3 inches and fire another round of 3 test shots. We can see that we now have our shots at the correct elevation, but we are still off to the left side. Now we adjust for windage on the horizontal axis. By moving our focal point about 3 inches to the right, we now see that our test shots are hitting in the center of the bullseye. We have successfully used MOA to help us zero in our scope and to make consistent bullseyes. We will be right back after this quick message. In summary, we have now learned that a minute of angle is 1/60th of 1/360th of a surrounding circle at 100 yards. We've learned how to calculate what adjustments need to be made to put our focal point on the bullseye. We've learned how to calculate our adjustments to our scope based on the knowledge of how MOA works. I sincerely hope that this has taken the mystery out of MOA and how to make the most of using MOA to adjust your scopes for accuracy. Please be sure to give this video a thumbs up to help me score a hit, and subscribe to this channel for additional lessons on crossbows. Please leave your comments below and I will try to reply as soon as possible. Thank you for watching and enjoy your crossbow.